Okay, we have one last routine to do on this side after the chamfer, and that's cutting this floor in the on this side. And so we're going to go in with a 2D, and we're just going to do a small pocket, and we're going to use the 1/8 inch end mill. Okay, we're going to leave it all default feeds and speeds. Our geometry is going to be this pocket here. We're going to go to heights. We're going from model top and model top. We're going to go to the selected contours and depth. We're going to look at all this. We're going to use morph spiraled. I don't think it's necessary to multiple depths because we're going to do multiple depths because we want to have one rough and one finishing. So we're going to do one finishing step down, and we're going to take off 0.01 10,000ths for that finish cut. Order by depth is fine. Finishing passes on the sidewalls I don't believe we need, and we're not going to leave any stock. We do want to turn on smoothing and feed optimization, and then we're going to go in our maximum step over is going to be 0.0625 16th. And our maximum step depth is going to be the same, 0.0625. We're going to go to the next tab. We're going to have our horizontal lead-in race is fine. Actually, horizontal lead-in race is going to be 0. Sweep angle is going to be 0. Our lead-in is going to be 1.07, a little over half the diameter. No vertical lead-in. We're going to plunge. And let's hit OK. Alright, so we get our 3 passes that'll take out whatever material's left in there. The first pass may not remove anything because the ball cutter that came in there, it's going to leave a scallop there, so it might just skim the very top of the scallop on that first cut. Alright, sequence wise I kind of forgot to do this, so I want to put this in a little bit higher. We're going to put it right after the trace. And I also forgot to change the name of this roughing to finishing. Okay, so we have our roughing cut and our finishing cut. Okay, now we can move on to op 2, which we can copy a lot of what's in op 1. So on the second side, we're going to switch our vices. Okay, so we should already be set up for where it's going to be. And we're going to make a new setup. Okay, and on this one, what we're going to do is we're going to base this off X and Z axis. So we should be able to pick a plane that's normal to Z, and then we need to pick an edge that's normal to X, and it looks like we need to flip it, have it the right orientation. And instead of a stock box point, we're going to go to a model box point. And we're going to select another one in the bottom left corner, which lines up with how we assembled our part. Okay, and our body is there, and we're good there. So our stock, it's okay to do it from previous. We're going to go to post process, and we're going to call this 7311 2. That's the second op 2. And we're going to do a work offset of 1, which is G54. We'll hit OK. We're going to change the name of this to op 2. And we're going to actually look at the note that we put on the first one. We're going to highlight all of that, copy it, Control C. And we're going to right click on our new operation And we're going to edit the notes on that one. Hit Control V. And we're going to change the verbiage. So the WCS origin is the back left bottom corner of machined part. Okay, and we're going to use 1 3/8" tall parallels. And we're going to bump our clamping pressure 10 foot-pounds. It's 3 clicks on our wrench. The reason is we're going to probably take a more aggressive approach to roughing what material's left on this part here. Okay, we're going to hit OK. Now we have Op 2 set up. We're going to work on the other side here. So we're going to use the same face mill and the same contour. So you can right click on, highlight those and right click on it, copy. We're going to highlight our Op 2 and we're going to do a paste, and that'll copy those to the other side, although we're going to reverse the order. And the reason is the contour is really just to knock off these corners so that our face mill isn't cutting through a real thin profile that's unsupported. So we're going to go to the contour and we're going to go edit. Okay, and we're going to keep the same silhouette geometry is fine. We're going to go to heights and we're going to leave it at stock top, stock top. We are going to select a different edge, I believe. See what edge is selected. Yeah, the original edge is fine. It's right here. And we're going to go -10 thou past that, just to make sure we're going past. And then our linking side, we're going to leave all this the same, except for when we come down here, we're going to leave stock to leave. And we're not going to leave any axial, but we're going to leave 50 thousandths radially because we don't want to remachine surfaces we've already touched and getting witness marks on them from cutter mismatch. We're going to go to the next tab, and everything can stay the same except for our entry point. We're going to select an entry point on the front so that we can see where that's approaching the part. Okay, we're going to hit OK. There we go, and we've got our lap around the top. Now we're going to go to our face mill. We're going to edit that. We're going to go to geometry. It's the same profile. Our heights are the same. On passes, we are going to do multiple depths. Our maximum step down is going to be 0.25, half diameter. We're going to do a finishing step. We're going to use even step downs. And our finishing step down is going to be 0.01, so 10 thousandths. We're going to go to the next tab. We're going to leave all this at default and hit OK. So now we've milled down our top surface with our face mill. Alright, more things to copy from the other side. We pretty much have this same feature on this side. It's symmetrical. So we did that with a trace, a second trace when it was a rough and a finish. We did a pocket, and then we roughed the outside fillet and rough the inside fillet, or finish the outside fillet. So we're going to right click on those and we're going to copy all those, and we're going to go to Op 2 and we're going to do a paste on that one as well. So we should be able to regenerate these. So we're going to pick our trace, we're going to go edit. We're going to keep all the parameters the same except for we can go to geometry, and we're going to select a different open loop. And on that open chain, we need to put on the same extension we did before, which was half the diameter of the cutter. I think we did 0.26. Our height's going to stay the same. All this stuff's going to stay the same, especially with the axial stock to leave. and our linking, and leave it all the same. Okay, so there's our roughing cuts. Now we're going to do our finishing trace. Okay, we're going to go to geometry. We're going to clear the selection. We're going to select this other loop. We're going to edit. We're going to edit that chain, and we're going to put in 0.3 for both. That gives us our finish. And we're going to leave all this other things at default. Hit OK. And we've now finished the fillet there. Okay, now we're going to go to our pocket. Go edit. We're going to pick the same chain for the pocket from the opposite side. We need to deselect the chain from the opposite side. And we did an extension on that one as well. Or did we? Okay, heights are the same. Passes should be the same. Lead-in should be the same. We're going to hit OK. Alright, there's our finished. It'll remove the little scallop that's in the center. Now we're going to do our outside. We're going to go edit. It's roughing. We're going to leave all this the same. We're going to go to geometry. Honestly, the profiles are the same. Okay, we're going to go to heights. Our selection point has got to change. So we're going to clear out the selection point we did before, and then we're going to put in a new selection point, and we're going to have the cutter go to the same level below. Now this one we got to really make sure that it doesn't gouge into the top of this. On our geometry we did have some avoidance groups, and so we need to edit that. And we don't need to avoid the opposite side of the part. So we can deselect all those features. But we need to select the similar features on the opposite side. Okay. Most of the rest of this should be the same. We hit OK. Okay, what we do need to do is do a reality check. We're going to look down here. Is the tip going to hit our steel jaw? Okay, it does not look like it. It looks like it's correct. Hopefully our jaws are modeled correctly. You could set this up as fixtures to avoid, but we've effectively done what we need to do there. Now we're going to go to our finishing side. We're going to go edit. And we need to do similar selection differences. Okay, so we're going to go to the geometry. We're going to edit this avoidance group. We're going to deselect the stuff on the opposite side of the part. That's irrelevant now. We don't want it going out of its way to try to, I've had sometimes the software try to machine something it's avoiding. Okay, and then we need to add the avoiding surfaces on the opposite side. And we hit OK. Alright, so we should get a good machining there, although what's going on here? We're plowing into the table. Okay, this is a bad mistake. See how it's going through the steel jaw? because I forgot on here to select a new point. And now we should be going to a reasonable spot that will not gouge into the steel table. Okay, so that's it for everything except for the countersink on this side. There's two ways you could approach this. You could use a spot drill, or you could use a chamfer mill. Either way, if your part's misaligned, it's not going to work. I think it's a little faster to use a spot drill, although it's probably going to chatter in this context. So let's use the chamfer command that we used on the other side. So we can just highlight that. We're going to do a copy, highlight op2, and do a paste. And then we're going to pick up on that chamfer mill. We're going to go and clear out the previous selection, and we're going to pick the top of the hole. Make sure the arrow's on the inside. Leave everything else at default, and hit OK. And then we should get a nice chamfer on the opposite side of the hole. Okay, that's it for the 7311 pivot arm. Remember, you need to post-process 2 programs and create 2 setup sheets. It's part of the homework.